When my colleagues and I make courses about a topic like CSS, we either provide a broad overview or we go into great detail on some project or specific technique or feature. That leaves out all these little nuggets of information and insight which don't quite fit or there just isn't time for. Today, in this course, I'm going to fill at least part of that gap. Watching this course, you'll get a long list of CSS tips you can take to heart and use right away, each packaged in a single movie and addressing a single tip or technique or issue or clever workaround. Watch the course in order or in random order or pick and choose the tips that sound interesting to you. Consider this a curated list of Morten's hard-earned insights about CSS and how it works, and use it as a reference to flesh out your own understanding and skill with this coding language. CSS has a ton of lesser known or lesser understood or lesser used. Whether you're new to CSS or you've worked on the front end of the web for years, there's every chance you've heard of and probably also used a CSS reset or a CSS normalizer. In many tools and frameworks and project templates, CSS resets are a standard feature, but it's worth asking the question, should we be normalizing or resetting our CSS? And should you be normalizing and resetting your CSS? So let's take a look at why these tools exist first. If you open a semantic HTML document without any CSS in the browser, you'll notice something interesting. Even though you provided no styling, the document has styling. There are different heading levels, block quotes, and figures are indented. There are table styles. Things are presented in a reasonable way in the browser. This is because the browser has a built-in style sheet called a user agent style sheet or just user agent styles, and those styles are there to style unstyled content, which makes sense since unstyled content should still be presented in a reasonable way in the browser. Now, there are two challenges here from a web development standpoint. Number one, these user agent styles are opinionated and don't necessarily match with our intentions, so we have to override them with our own styles. And number two, there are slight differences between the different user agent styles in different browsers. I urge you to take this HTML document that's sitting in the exercise files and open it in multiple different browsers and scroll through it. And you'll notice that even though it looks roughly the same, there are some slight inconsistencies between the browsers, which are worth knowing about. CSS resets and normalizers were introduced to fix this problem, and they did that by overriding all user agent styles, so you started with an absolute clean slate. The first CSS reset I'm aware of was the one that was created by Eric Meyer way back in the day. And now he has updated his reset several times, and while the old reset truly reset the entire browser so you had no user agent styles, the new reset is a lot more, shall we say, rational and careful, so it doesn't override everything. This reset is the classic reset that people are using. A more modern reset is called normalize, and this is one you'll find in a lot of templates and projects and things that you download. Normalize is also more careful in how it approaches things. You can see it's currently in version 8, so it continuously evolves and tries to provide a more reasonable alternative to a hard reset. In addition, we now have a third option, which is called CSS Remedy. Now, CSS Remedy is very different from the normalize and CSS reset, because instead of trying to reset styles in the browser, CSS Remedy says, what is the actual intention of each of these elements? What should they display like if HTML and CSS were working properly? And then the remedy tries to set all the elements to display the way they were intended to be displayed had the specification been read properly. It's kind of funny since it's developed by a lot of the people who write the specification and implement the specification. So you have three very different approaches here, and they fall into basically the three different factions within the should we be applying CSS resets to our project or not debate. The three factions are, number one, those who believe normalizing and resetting CSS is the best solution and should be done all the time. Number two, those who believe building on top of the user agent styles is the best solution. And number three, those who believe fixing user agent styles to match the original intent of the specification is the right solution. Where do I land on this? I am verging very closely to CSS Remedy or no reset at all, because I've realized that I'm introducing a lot more CSS than I need to by trying to reset things, but different developers fall in different categories and different communities fall in different categories. So what I've done here for you is set up a test environment where you can test these CSS resets and see what they do to your page. In the exercise files, you'll find a document called index.html. And at the top here, you can see we have calls for different resets. So I have the reset that Eric Meyer created. I have the current version of normalize, and I have the current version of remedy. And if you want to see the effect of any one of these, you can simply uncomment one of these links. This is the reset. Remember I said a full reset literally resets everything, so you have no pre-configured styles at all. So everything looks the same here, which is very useful if you want to start from scratch, but it can also be absolutely not what you want. It all depends, because by doing this full reset, you're also introducing a lot more work for yourself. Normalize is more careful. So when I apply normalize, you'll notice it looks similar. There are some changes. It's actually a good idea to do a side-by-side comparison here to see what normalize does. And remedy is even more subtle. So remedy makes some small stylistic changes and introduce more consistency and does things like remove the margin around the body. It makes images into block level elements, and it does other things that you would expect or you would have to do manually anyway. But like I said, they're all very different. So now that you have this document, if you find a CSS remedy or reset or normalize you want to use, I encourage you to dump it into this document, which has every possible HTML element, and then see what that reset does to your content before you start using it. This becomes your test bed for resets. Modern code editors and IDEs come with useful built-in tools like syntax highlighting, which help you detect errors and write cleaner code. You can see as an example here, I've forgotten to add a curly bracket, so therefore the syntax highlighting is wrong in this document. And also, if I hover over this squiggly line here, it'll actually tell me there was a curly bracket expected and it's not there. And then I can fix it by adding in the curly bracket. This is really useful, but if you want to bump things up a notch, and you probably should, you can introduce what's known as code linters. These are tools that check your code against predefined rules to make sure the code is consistent and without errors. Linters are great for everyone who writes code, and they're especially useful if you work on a team or you publish your code to a platform like GitHub, because they enable you to enforce strict rules for code and formatting so that your code remains consistent regardless of who is working on it. Now, there are linters for most coding languages, including CSS, and in CSS, my preferred linter is called stylelint. It's what you see here, and you install it using npm. Let me show you how I set up stylelint and the prettier code formatter together in VS Code so that my CSS is automatically linted, cleaned up, and formatted as I code. This requires a couple of steps and it has to be done in a specific order, so I want to walk you through this process. This all starts in your project. So in my project folder, I have two files here. I have the style sheet, and I also have a file called package.json. This is the npm initialize file that sets this up as an npm project. And this is necessary so that we can add dependencies to our project. The next thing I need to do is add stylelint into my current project. To do that, I can go to the stylelint website, go to getting started, and here is the code I need. So I'll copy out this line of code here and go into the terminal in VS Code and then make sure I'm in the correct folder, so 01, 02B. And here, I'll just paste in the code. So it says npm install, save dev, meaning this is development code, not production code. And then I'm installing stylelint, which is the application, and stylelint config standard, which is a standard configuration for stylelint. You can change that if you want to, but this is what I normally use. Hit return, and now npm goes onto the internet and pulls down these two packages and installs them inside my project folder. Once npm is finished installing, you'll notice I have a new folder called node modules that contains all the modules that were downloaded. I also have a file called package lock that just sets the version number for these different packages. And inside package.json, there are now some new references. They're down at the bottom here. Dev dependencies, stylelint, and stylelint config standard. That means everything is installed. The next thing I need to do is tell stylelint how to operate, and I do that using this file called stylentrc.json. So I'll copy that file name and create a new file in my folder with that name. You'll notice VS Code automatically detects, oh, this is a stylelint file, so it adds the stylelint icon for me. Then I need to set up the actual configuration. So I'll copy this piece here, extends stylelint config standard. That's what tells stylelint which standard to use. So that's the standard we downloaded just previously. And now that all of this is installed, I'll go to the extensions in VS Code and search for stylelint. This extension will detect that I have a stylelint install and automatically apply it to any CSS file I open. And you noticed all of a sudden there was a change up here in the toolbar. The style suddenly got a red text on it, and there's a 9+ next to it. If we go back and look at this file, you'll now notice there's a ton of errors that weren't there before, because now stylelint is observing the code and saying, hey, you're not following the rules here. So stylelint is now linting my code, detecting errors and telling me what to do. So here it'll tell me there's a trailing semicolon missing, so I need to add that for the error to go away. And as I scroll down, you'll notice this error repeats a lot because this style sheet is really messy. There's also some other things here. There's some indentation problems missing. There's some shorthands that need to be there. So this is just telling me there's a lot of problems with your code and you need to fix it, which is great if you're writing CSS. It's not so great if you are working with existing CSS. Like here, you see the red line on the right-hand side here is telling me where there are errors in the code. And they're basically errors in the entire style sheet. So I have some work to do. Good news is I can hook in this second tool called Prettier, which is a code formatter that automatically tries to format and clean up my code for me. Prettier is installed in the same way. So we'll go back to the terminal and say npm install save dev Prettier. It gets installed into my project. Then I need to install this package here, stylelint config Prettier, because the Prettier standard configuration conflicts with some of the stylelint configurations. And this particular configuration will override any stylelint configurations that conflict with Prettier, and therefore everything will work properly. So down here I have the code I need. npm install save dev stylelint config Prettier. I'll copy that and paste it into my terminal. And once that's installed, I can go and extend my configuration for stylelint to also include stylelint config Prettier. I do that by going into stylelint RC, and where it says extends right now, I need to turn this into an array. So I'll put square brackets and then a comma here and paste it in. So now what will happen is stylelint will try to use stylelint config standard, except in the cases where stylelint config Prettier overrides it. Okay, save that, and the error messages will still be the same, but now Prettier can do its job. To get Prettier to work, I have to go back to extensions and install Prettier as well. So I'll search for Prettier code formatter, and install it. Once Prettier is installed, I need to set a configuration change for VS Code itself. So I'll go to Preferences and Settings. Here I'll go to Workspace and then search for Formatter. Here you'll find the option Editor Default Formatter, and you want to use the dropdown to find Prettier code formatter here. And then you can choose how you want to apply formatting. And I like to set this to format on save so that every time I save something, the formatter kicks in and cleans up my code. All right, now that I've done all that, I can go back to style.css. And if everything works correctly now and I save the file, you should see things being cleaned up. Did you see that? Notice the red line on the side here suddenly got reduced to only a couple of red dots. That's because there are some actual errors in the CSS, but everything else got cleaned up. All these semicolons at the end got cleaned up. The code is formatted much differently. Indentation is cleaned up. Basically, all the formatting of the style sheet has been cleaned up, and most of the errors have been automatically fixed thanks to stylelint and Prettier working in combination. And that's what I'm saying. If you're working with CSS, having these two tools set up in your project will save you a ton of time and help you write better code. When the viewport height and viewport width units, so VH and VW, were introduced, they changed the way we do web design, because for the first time we were able to say this element should be either the full width of the viewport or it should be some percentage of the width of the viewport. Before we had these units, we had to do math to figure out what those were, or we have to use JavaScript to measure the size of the viewport. This led to a new trend of creating full width or full bleed layouts where you had maybe an image that spanned the full width of the viewport. However, using VW to do this introduces an interesting and kind of infuriating problem, especially on Windows computers. And this is not because Windows is doing anything wrong or because some browsers are doing anything wrong. It's because the spec is interpreted in a very specific way that runs counter to how you would expect it to behave. So let me show you what this problem is so you're aware of it, especially if you're working on a Mac, so that if you encounter it on a Windows computer, you know what's going on and you will be able to create a workaround to solve it. To show you the problem, I need to change the width of one of these items. So right now, this title thing that's here has a width set to 100%. So let's say I change the width of it to 100 VW. When I save this now, the width of this item will be 100% of the viewport width, but because it's aligned with the parent container, it looks weird. So we have to scroll to the side to get to the whole thing. And we could fix that by doing math and figuring out how wide the container is and then shifting a negative margin over to the side. So I've just done a rough calculation to figure out what that is. And it's 7.4. So I've just set a negative margin so that we get the full width of it. Now notice this, even though this item is now edging up against the left side of the viewport and the right side of the viewport is over here, I still have a scroll bar. There's a tiny little bit of scroll here. And if you pay close attention, you'll notice that the scroll is equal to the width of the vertical scroll bar. And this here is the problem I'm talking about. Because when we say 100 viewport width or 100 VW, we're saying the width of the viewport, including the scroll bar. But the browser will want to show us everything that's within the viewport display, which is why it's also showing this scroll bar down here. The reason why you don't see this on a Mac is because in a Mac, the scroll bar disappears when you're not interacting with the page. So it only appears if you're doing scrolling behavior, and it's kind of overlaid on top of the content. But on Windows computers, the scroll bar is always present, so therefore you get this horizontal scrolling. This is really annoying, and it causes unexpected behavior because you're suddenly seeing the scroll bar and it looks like there's something wrong and you can't quite figure out what's causing it. It gets even worse if you try to do something like the same thing with an image, which is what we normally do. We want these full bleed images because now you have this horizontal scroll bar, and if you had some important information or maybe a border on the image or something else, it would get covered. So this is not ideal, and it's not what we want. There's a workaround to this. You can go to the body element and set overflow X, so overflow in the horizontal direction, to hidden, and that takes the overflow away. So now we don't have the scrolling, but that also means that whatever data is sitting here on the far right-hand side is lost because it's behind the scroll bar. And there are some other reasons why you shouldn't just block overflow globally on the body object, because there may be things that are supposed to overflow, or you're maybe hiding other problems that you're not aware of. So this really isn't a good solution. Which begs the question, if I want this kind of layouts, but I can't use 100 VW because of this weird pesky problem, what do I do then? So let me show you one solution that bypasses the problem, and it's actually how we solved the same problem before we had VW. So what I need to do then is say, instead of setting a max width for the demo area, so just for reference, demo area is the container that holds the image and all of this text and the title and everything, I'll set it to the first level children of demo area. So I'll say demo area's first level children have a max width of 40 rems. Save that. Looks a little bit strange right now. That's because we have this margin left thing that shouldn't be there. So I'll take that out. And we also lost the vertical. Oh, right. So I need to set margin right to auto and margin left to auto. And then we have the intrinsic margins for the rest of the items. So now everything is working the way it's supposed to. Then if we want this title to be 100%, we set it to 100% of its container, which is demo area, which we haven't defined a width to, so it'll be 100% of the available space. So therefore I can go down and say width is 100% and save. That changed nothing. That's because we set max width to 40 because this is a responsive layout. So we have to say max width 100%. Now it's 100% of the available space. But as you can see, there's some extra margin on the side here. That's because the body element has a default margin in the user agent styles. So I'll say margin 0. And now we can finally do the same thing with the image down here. So if I go find the image, it's currently set to width 100 VW. I'll set it to max width 100%. And we get a full bleed image. Now, this approach that I just showed you is really clunky because what we're doing now is saying we have a container that is the full width, and then we take every single element within the container and constrain its max width so that it's centered, like the paragraph here, and then we override these styles for the ones that we want to be full bleed. But when we do this, we don't have this weird overflow problem that we get with VW. Hopefully in the future, this will be solved via either the browsers or the spec or something else, but until then, use VW with care and test in multiple different browsers to make sure you don't get this weird scrolling behavior, because it really does cause unexpected user experiences and users are really confused by it. You have an element like this second paragraph here, and you decide you need to add some padding inside to give the contents of the elements more breathing room. So I go in and add 1 rem of padding, and as a result, my box grows. You see, if you set the width and or height of a box, as I've done here, and then add padding or border or both, you're adding to the width of the content box, so the overall size of the box grows. You have to imagine there's a box around the content, and the padding goes on the outside of that box. That's because the default box sizing setting for all elements is content box, meaning the box size is applied to the content inside the box. The same thing happens if we apply a border. When I apply a border, the overall size of the box keeps growing. When you're working with advanced designs and want things to line up, this is rarely what you want. To solve this problem, we can change the box sizing value from content box to border box. So let's do that on the element. Box, sizing, border box. Save, and the width of the second box is now the same as the width of the first box. This is because the size of the box is now applied to the outer edge of the border box. That way, when we add padding or border or both, the size of the box doesn't change. Instead, the content area inside the box is reduced. Now, it's become common practice to apply this as a global reset to box sizing for all elements because the behavior is more in line with what our minds expect when designing boxes. That's done by adding a rule at the very top of your style sheet. So I'll cut out box sizing border box, go to the top of my style sheet, add a new rule for asterisk, meaning all elements, and inside the rule I say box sizing border box. Save that, and the behavior remains the same. We are now sizing our boxes to the border box rather than the content box. My recommendation is to do this, apply box sizing border box as a global rule, and then in the few situations where you actually want the content box to control the size, then apply box sizing content box as a special rule only to those boxes. The classic box model uses directional properties: top, right, bottom, and left. So for example, if you want to add a vertical border to the front of a block quote and you're working in a left to right language, you would add a border left and a padding left to make that happen. But if you were to go in and change the text direction here from left to right to left, this doesn't look right. It's not behaving the way we want to. As a result, if you're working with a multi-language site or app and you need support for both left to right and right to left languages, you need to set up 2 separate style sets or 2 separate style sheets, one for left to right languages, another for right to left languages, which is not great. It also highlights a larger problem with the directional properties. As our tools evolve, top, right, bottom, and left make less and less sense because we're changing things around and operating with elements in a different way. Instead, we should be thinking about the logical behavior of the properties. This is a traditional box model. We have top, right, bottom, and left, and these are all related to how we view the content in the browser window. When we want to add padding or border or margin, we always refer to these, or if we do the shortcode and just say margin : we are going top, right, bottom, left as our values. As the web evolves, so has our box model, and there's now a new way of thinking about the content within the box model, and it's called the logical box model. So instead of saying top, right, bottom, left, we say inline direction, as in the line the text flows inside the box, and the block direction, which is the vertical or the cross axis to the inline. And we can use this inline direction and the block direction to change our behavior when we add padding, border, margin, and other properties. So if we have a box and we want to change the width of the box along the inline axis, meaning along the line the text flows in, we would change the inline size. So instead of width, we now say inline size and then the same value. If we want to change across the cross axis, the axis that goes perpendicular to the inline, we change the block size. So instead of height, we say block size. And it gets even more interesting. In place of top, right, bottom, and left, we can use those same references. So we say for top, it's the start of the block direction. So that would be block start. For right, it's the end of the inline direction. So that would be inline end. For bottom, it would be the end of the block direction. So that is block end. And for left, it would be the start of the inline direction. So inline start. That gives us the complete logical box model. We have inline direction and block direction, and we can target each of these items separately using block start, inline end, block end, and inline start. So let me reset my example here and see if we can fix this weird problem I created for myself by using these new logical properties. In my CSS, I currently have border left, meaning I'm placing a border to the left-hand side. But what I really want to do is place a border on the inline start side. So instead of saying border left, I can say border inline start. And instead of padding left, I can say padding inline start. Save this, and it looks exactly the same in the browser because inline logical component is the same as the left or right component. And now, when I change the text direction down here to RTL, you'll notice the inline direction changes because the text direction changes, and as a result, I now have the border on the correct side. So these logical properties relate directly to text direction and also writing modes. And that means once we start using border inline start or just inline start and inline end and box start and box end, we can more tightly control how the boxes behave, and we don't need to create these custom style sheet for RTL or other types of writing modes. CSS writing modes lets you control whether lines of text are displayed horizontally or vertically and in what order each of the lines are displayed. This feature is necessary to properly display vertical and vertical reverse languages and can also be used to create new typography effects. If we go to our CSS, we can set up a writing mode property. You can see I've done it here and I've set it to horizontal TB. When I set writing mode to horizontal TB, you'll notice in the browser, nothing happens. That's because for left to right scripts, content now flows horizontally from left to right, and each horizontal line is positioned below the previous line, which is what we normally see in left to right languages. If I switch the text direction to right to left, you'll see the same thing. So the text will flow from right to left, and then the next line will appear under the previous one. Horizontal TB is the default for most European languages and also the default for most browsers. Now let's see what happens if I change this value from horizontal TB to vertical RL. Now for left to right scripts, the content flows vertically from top to bottom, and the next vertical line is positioned to the left of the previous line. The effect is it looks as if we just tilted the text on its side. So it's now read vertically instead of horizontally, but the formatting of the text is the same. If we switch to a right to left language, the only change would be that the first line would be on the left side and then the next line would be on the right and so on, because they're right to left languages, so everything is written in the opposite direction. But it's still recognizable as regular text, and as you can see, you can use writing mode vertical RL to tilt text in a 90-degree pattern on the page. That brings us to the third option, which is vertical LR. And by process of elimination, you should be able to guess what happens here. So when I save this, you'll notice the text is still flowing top to bottom, but now the order of the lines has been reversed. So now we have the first line to the left, and then the next line comes to the right of that, and so on. This makes no sense when we are turning English text on its head because it becomes very difficult to read. But you can imagine if you're reading a language where each of the characters is stacked vertically and you still want to read left to right, this actually makes sense. Now, the reason why we have these three options, horizontal TB, vertical RL, and vertical LR, is because those three options combined with the RTL functionality allows us to display text in any way that we could conceive of text being displayed in a normal language. Now, In a different movie, I introduced CSS logical properties, and I said inline and block direction relate to text direction. That means when we change the writing mode of an element, the inline and block directions of the logical properties change as well. If you look closely at the block quote markup here, you'll notice that in place of using margin and width and border and padding, I'm using margin inline start, margin inline end, and then inline size and border inline and so on. So you notice there's a lot of inline going on here. That's because I'm trying to control this box so that the indentation and the border and the margin and the padding and everything else is still working the same even if I change the writing mode. Let's see what happens, for example, if I change this from vertical LR to RL, so that it's a little more recognizable, and then go and change inline size here, which is controlling the width of the content. So the length of the text line here from inline size to just width. Save that, and the display is not what I want at all, because with width, which is not a logical property, we are saying the width of the container inside the viewport, so the horizontal width is 40 ch. But because I've now turned the content using writing mode, I can't use width anymore because it doesn't denote the actual width of the content. Instead, I have to use inline size, because as a logical property, inline size will follow the writing mode, and therefore the width will be set the same regardless of what direction the text is displayed. Bottom line, if you plan on using writing mode to change the display of your text, make sure you use logical properties as well to format the box itself. One of the great challenges of front-end web development is aligning content within a container, especially centering content within a container. Well, I should say it used to be one of the great challenges because we didn't have the right tools for the job, but now we do. Let's say you have a container, like this big gray area here with a defined width and height, and you want to center another element inside that container. The modern and most straightforward way of doing this is to set the parent container to either flex or grid, depending on what you want to do next. They actually work very similarly. There are a few differences, so let's look at both and see how it all works. I'll start by setting the demo area to display flex. Save that, and immediately the container turns into a flex container and the child turns into a flex item. And you can see by default, a flex item will take up its intrinsic width, meaning the width of the content inside the child, and will also take up the full vertical or block space, which is not what we want. So we need to make some changes. Now, if the parent has only one child, as is in the case here, you can use justify content and align items to position that child within the parent container. So here we're using the parent container to control the position of the child item. So I'll say justify content and then set it to center. This is a logical property. And what we're doing now is saying along the inline axis, place whatever child is here in the center, which is why we now have the content in the center. Then we say align items, align items, and set that to center. Save again. And now the item is positioned in the center of the block axis as well. And as a result, we get a perfectly centered item. The key to remember here is justify content works along the inline axis, as in justifying text on a line, and align items works along the block axis. So if we change the writing mode here, these are logical properties and they'll turn along with the writing mode. All right, so I did say that flex and grid work the same way here. So let's see if I just change the display of the demo area to grid and save. Nothing changes. Well, nothing changes because it works exactly the same. But there is still a difference between flex and grid. So let me switch it back to flex and then show you a different approach to this same problem. Right now, we are using demo area to control where the child element should position itself. But in some cases, we want the child element to position itself. In that case, we would take out these two declarations. Then we go into the child item when we say align self and set that to center. Save, and now the item will align itself to the center of its parent container. However, if I now say justify self, center, you'll notice nothing happens. Why is that? Well, it's because we are working with a flexbox, and we are now trying to position the child item inside the parent container. But flexbox works from the element out, so it has no control over the display of the parent container. And since it's taking up the intrinsic size it's supposed to, this doesn't work. So if you want to center a child item and you want the child item to center itself, you need to change the parent item display from flex to grid. Because when we're working with grid, we are saying this is a layout in format. So we are imposing a layout. And in this case, the layout is a full space that the child item can position itself in. And therefore, we can both justify and align the child item. These new layout modules and logical properties give you complete control over the position of flex and grid items within the available space. And combining flex and grid level justify content and align items with individual items, so justify self and align self, you can create truly custom layouts without doing anything to your markup. Responsive containers, like the gray bar at the top here and the image below, want to reshape and take up all the space made available to them. That means whatever width or height or aspect ratio your container has when it gets loaded into the browser, when you make the viewport narrower, the container is squished and the aspect ratio changes. So I start with a square image, but as I reduce the width of my browser, the image does not stay square. Now, in this case, in my example, it's because I've set the max inline size of the image to 50ch. That's so that it remains responsive. And then I've set the block size, meaning the vertical display size in this case, also to 50h, but this is a fixed size. The reason for that is if I take away the block size, we get the intrinsic aspect ratio of the image, and it's no longer a square. Now, of course, if it isn't a square, then it'll actually resize properly. But if I want it to be a square, so I want to use CSS to crop the image, I am in a bit of a bind. Now, there have been workarounds for this problem for some time, but all of them are pretty hacky, and they involve some form of adding extra HTML markup and then tricking the browser using padding and negative margin and a bunch of other stuff, which is never a great thing. We now have a CSS property specifically for solving this problem, aspect ratio. And it can be applied to any element, and when it's applied, it forces the box into that aspect ratio. So for my square image down here, instead of doing this, which is not working, I will simply take the block size away, and at the bottom here, I'll say aspect ratio 1:1. So 1/1. Save that, and it appears as if nothing changed in the browser. But if I now reduce the viewport width, you'll see that the image retains its aspect ratio as a square. So we are now imposing an aspect ratio on the image, and it'll remain a square no matter what space is available to it. That's the whole point of this property. You can see another example if we apply it to this container up here. So we have a regular container that just has a single line of text. And normally it will show the intrinsic height of the content inside, which is just this single line of text. But if I go up here and say aspect ratio, and then set it to 16:9, which is a standard widescreen display that you would see in a video. Save, and look at that. We now have a widescreen box. So this will also always retain its shape, 16:9, no matter what happens, which is really useful if you are going to post videos, because as you have experienced, if you've ever tried to create responsive videos, you have to apply a hack just to get the box that contains the video to not scale in a weird way. You no longer have to. Aspect ratio does that work for you. Now, the aspect ratio property is relatively new, and as of this recording, it's not supported in all browsers. But I expect we will see support in the very near future because this eliminates the need for a bunch of costly and complex CSS hacks in JavaScript, and this is something the web development community has been asking for a very long time. Now that we have flex and grid, I often get asked if float and clear are still relevant. The answer is, of course they are. And now, for the first time, we get to use them the way they were intended to be used. The float property, as applied to this image here, places an item to the left or right side inside its parent container by removing it from the normal flow of the container and literally floating it within its context. The remaining elements in the same parent container then flow or float around the floated container, filling up the available space. In a text editor, we would call this text wrap, and you can see it pretty easily if I go and change something here. So I'll say float right, and then the image floats over to the right and the text flows into the available space left behind. Once we float an item like this, it's often necessary to control what happens to the adjacent siblings, so the text also appears inside the same container. Do they fill the available space as they do here next to the floated item, or do they appear on their own line? That's where the clear property comes in. Now, in the good old days of float-based layouts, we used a clear property a lot as part of a clearfix to ensure containers didn't collapse. And this introduced quite a bit of confusion about what the clear property is actually for and how it works. So let me explain. If you apply clear right to any of the adjacent items next to a floated item, you are saying no item can float to the right or left of this item. Instead, the item is placed directly under the floating item as if it were a block item. So if we look at the layout here, you can see we have this H2 that sits next to the image. Now, if I go to this H2 and I say clear left, we are saying no floated item can appear to the left of this container. So if I save this, the container drops down to its own line and appears as if it were a block item. This is what the clear property does. It clears whatever is on the left or right, saying nothing can appear next to me. You'll also see this very clearly if I then go and change the float to right, because this clear left says no floated item can appear to the left of this container, but now that the container is sitting on the left side, there's nothing more to the left side, and therefore no clearing happens. If I wanted to clear the same content in this context with content floated to the right, I would have to say clear right. Save that. Again, the content is cleared, and my box appears below the bottom line of the image. Finally, you can set clear both. Clear both just says, I don't really care if items are floated left or right. I don't want any item floated next to this item, so therefore you'll just clear both items. And this is often what you see in practical use, because if, for example, you were dealing with a right to left or left to right site, so maybe two different languages, then you'd have to either clear left and clear right separately, or you could just say clear both. Bottom line, clear prevents adjacent siblings from appearing to the left, right, or both of any element, and that's what they're for. And now you see how it works and how it can be very useful when you're creating your own float-based layouts. One of the many persistent headaches of creating websites on the old web was ensuring parent containers did not collapse when one or more of their children was floated to the left or right. Example, we have an image inside a parent container, and if I go and grab the image and set it to float left, the parent container collapses. So you see the image is spilling outside the bounds of the container. This is rarely, if ever, what we want. Setting an item to float left or right pulls that item out of its context, and as a result, the containing box collapses down to the intrinsic size of the non-floated items, which is the text here. This is hardly ever what the developer actually wants, and it can be a real frustration. To solve this problem, we used to use a clearfix that you can see over here. The clearfix is a CSS hack that introduces an empty pseudo-element at the end of the container down in the bottom corner, and then clears that one left and right to force the box to be the full size. So you'll remember when we talked about clear that we're saying nothing can float to the left or right of me. Well, by placing this empty container at the bottom, we are then forcing the intrinsic size of the box to match the bottom line of the image. Now, when I apply the clearfix, it works properly and we get the behavior we're expecting. But this is a hack, and it introduces some interesting issues, especially around flex and grid, where each of these pseudo-elements becomes a pure grid item. The good news is there is now a display value to solve this problem for good. If we take away the clearfix here, and then go to the parent container, and set its display to flow root. And save. You'll see we get the same effect. What happens now is with flow root, the parent container becomes a block level box with its formatting root set to the bottommost edge of its children. And the result is the box doesn't collapse even if the children are floated, because flow root says find the bottom edge of whatever is the lowest point in the layout and its children, and then place the root of the box there. So that means we now have a properly formatted box that doesn't collapse without a clearfix. Now, if only we had this solution 10 years ago when we were actually doing float-based layouts, that'd be good. When sizing text using CSS, we tend to use one of three units, either the fixed pixel unit or the relative M unit or rem units. With responsive web design, the recommendation has long been to use relative font sizes so they can change and adapt to the environment, and the default for a long time has been the M unit. Now that default is shifting towards the rem unit. I think it's useful to understand what these units are and how they interact, so let's take a brief look at pix versus M versus rem. The pixel unit is the easiest to wrap your head around because it's an absolute length unit. Set the font size property of a document to 20 pixels, and font that isn't otherwise styled will always be exactly 20 pixels in size. You can see that here, this is a 20 pixel font, and if I highlight it in my browser developer tools and go to the computed styles, down here it says font size 20 pixels. If I then go and change it to 16 pixels, like in this example here, then the font size is always 16 pixels. It's a fixed unit, so it remains exactly the same no matter what happens. Then we come to the M unit, which is a relative length unit, meaning its calculated value changes depending on external factors. 1M is the font size of the parent container. So when you set the font size of two different elements to 1M, you may get different results. In this example up at the top here, we have some text set to the size of 1M. If I click on it, you'll see down here it says font size 20 pixels because the parent element has the font size of 20 pixels. But if I scroll down, you'll see here we have another element, and in this case, the font size for the container is set to 28 pixels, and that means the font size to 1M is 28 pixels as well, because 1M relates to the parent font size, so in this case 28M, even though the root font size is just 20M. So you can see this text sized with an M is much larger than this text, which is also set to the same size, which is 1M. I like to think of the M unit as being scoped to its parent container. Change the font size of the parent, change the calculated side of the M. This can get really confusing really fast, especially if you nest containers inside other containers and use M values within those containers, because you then get a lot of calculations that happen to figure out what the font size is, and you may easily get confusing and unexpected behavior. The rem unit does away with the problems introduced by M by setting the length of one rem equal to the font size of the root element. It's relative in that if you change the font size of the root element, then anything sized using rem changes. In other words, the rem unit is globally scoped, and you can see that in my example. Here's some text sized to 1 rem, and you can see if we highlight it, the text size or the font size is 20 pixels. If I then scroll down, we have another piece of text here that's inside the container with a font size set to 28 pixels. And if we inspect that one, you'll see the font size is still 20 pixels because it's relative to the root element at the very top here. So even though it's sitting inside a container with a different font size, the rem-sized unit remains the same no matter what. For this reason, I prefer using rem units. They require much less thinking, and they produce exactly the output I want every time. That said, I've seen some very clever setups taking advantage of the scoping in the M unit, so it's definitely still in use. You just have to think about what you're looking for here. Consistent sizing or some form of relative sizing based on the font size of the containing element. Typographers and designers have argued for centuries about what is the ideal character length for a single line of text. The general consensus is for most fonts and most languages, around 70 characters is comfortable, but it does depend on characters, font, language, design, and a bunch of other factors. So let's say you have a paragraph of text and you want to display it with a line length as close to 70 characters as possible. What do you set the width or inline size to? Using em or rem units, that requires doing some math. Like, let's see, the font size for the root element is 20 pixels. You can see that down here. And then if we want 70 characters, we would have to then take 70 and divide it by 20 pixels, except we would divide that by 10. So it would be 70 divided by 2, which gives us 35 rems. So if I then go to the element in question and set the width to 35 rems, and then go and count characters, I would be at roughly 70 characters, but it's relative to the font size and it's not very accurate and it's convoluted and error prone is what I'm trying to say. So instead, we'll use the ch unit. 1 ch equals the width of the 0 character in the current font. So if you want a line length of 70 characters, you just set the element width to 70 ch. I can do that down here with 70 ch. And now you notice two things. First of all, 70 ch is a different width from 35 ems. Remember I said the other method is convoluted and error prone? The second thing you'll notice is the character count is exactly the same across these two containers, even though the font size is different. And that's because the containers are now sized based on the character size in the container itself. So 70 characters in a much larger font will be a lot wider than 70 characters in a much smaller font. But you'll notice that the line breaks happen at the exact same spot in all of these containers because we are using the ch unit to define the size of the container. The ch unit is really powerful because it allows you to control the width of content based on this font, and it becomes much easier to use than anything else. But because the ch unit is relatively new, it's a good idea to provide a fallback in the form of a rem or em size, just so that users who have older browsers still get a meaningful size. And as you can see, you can do the math to figure it out, but in many cases, I just end up experimenting to see if I can match the size as closely as possible. A typical trait of responsive websites is snapping between breakpoints. That's what you're seeing here when we are snapping from a smaller font size to a larger font size. This is because the developer has to make choices about things like font size and layout for different viewport widths. And these choices have traditionally been rigid and codified in media queries, like you're seeing in the code example here. As a result, we get a setup like small screens get a base font of 18 pixels, larger screens get 20 pixels, and even larger screens get 24 pixels. And as the viewport is scaled up, you'll see the font snapping from one size to the other. This works fine, but it's a jarring user experience, especially if the user is not expecting it. Now, using the min, max, and clamp CSS functions, we can introduce more flexibility and nuance into this situation. So let's take a closer look at these functions. First, I'm just going to get rid of the media query here, because we don't need it anymore. We'll replace it with these functions. Then let's look first at the min function. Min can be applied to anything that has a size. So in this case, I'll say width and min. And this function lets you provide a comma-separated list of one or more sizes, and the browser will then pick the smallest of the sizes available for any situation. So in my example, I'll set up 40 ch and calc 100 VW minus 2 rem. All right, what happens now is the container width will be either 40 ch or the full viewport width minus 2 rem, whichever is the smallest. So if we go and look in the browser, you'll see what that means in practical terms. When I scale down the viewport width, so it's less than 40 ch, then the second condition kicks in. So in this case, we are now looking at 100 VH minus 2 rem. But when I scale up, 100 VH minus 2 rem will be larger than 40 ch, and therefore 40 ch kicks in and locks the width of this container. So that way we've created a responsive and scaling element without using a media query, where a media query would normally be necessary. And we have really detailed control over exactly what happens. And like I said, the min function can take many different comma-separated values, so you can very tightly control how this container scales depending on the current available space. Min always picks the smallest or shortest value. The max function does the exact opposite. So let's comment out this line here and set up a new width and set that one to max. Max works the same way as min, just in the opposite direction. So if I set the value here to 50 VW, that's 50% of the viewport width, and also 20 CH, we get a slightly different behavior. Here we're now telling the browser the container will be either 20 CH wide or it'll be 50% of the full viewport width, whichever is the biggest. So if I save this and do my scaling example again, you'll see that when we add a smaller scale, the container will be 20 CH because we're saying the bigger of the two values here is 20 CH, because if we set it to 50 viewport width, it would be less than 20 CH. But as I scale up the size of this container, we'll get to a point where 50% of the viewport width is higher or longer than 20 CH, and in that case, 50 VW takes over. So we're getting responsive behavior just in the opposite direction of what we had with min. With min, we are effectively setting an upper bound, and we're saying you can do all sorts of weird things, but here's an upper bound. You can't scale beyond this. Whereas with max, we're setting a lower bound and saying that you can't really scale any lower than this, but as you go higher, you can keep making things flexible. My recommendation here is to experiment with these values, slot in some different values and see what the behavior is like. And then as you're moving forward and trying to use this in your own projects, think of it like that. Min is usually used to prevent an item from growing too much, whereas max is used to introduce more flexible sizes at larger sizes. Which brings us to the third function, clamp. And this is probably the most interesting of the three. So let me just change my code example here so that we have the min set up again. A clamp literally clamps a value between an upper and a lower bound or limit with a variable preferred value in between. This is what it looks like. So I'll go into my element and say font size, where it's normally used, and then we'll say clamp. And then we need the lower bound, so that is the smallest size the font will ever be. We can set that at 1 rem. Then we need the preferred value, so that is the flexible value that we want to target whenever possible. And I'll set that to 3 VW. Now that is 3% of the viewport width, which sounds weird until you see it in this context. And then finally, we have to set an upper bound, so the largest a font can ever become. And just because I'm working with a really small screen here, I'll set that to 1.4 rem. So effectively what will happen now is as I scale the browser, the font will never be smaller than 1 rem. If it's between 1 rem and 1.4 rem, the browser will try to scale it in accordance with the available viewport width. So you'll get this interesting experience of increasing the font size as the browser window increases. And then when we hit 1.4 rem, which is the upper bound, then it'll stop growing. So save this. As you can see, we now have the smallest size, so this is 1 rem. And then as I start scaling up the browser window, at a certain point, 3% of the browser viewport width will be larger than 1 rem, and then the font starts growing. So you can see the font is growing here. And then at a certain point, we will hit the upper bound. Let's see, I might have to increase my browser width to make that apparent. So now we've hit the upper bound, and the font size stops growing. So now we've created this really dynamic, fully scalable font that will try to be responsive whenever possible, but still has a lower and an upper bound, so it'll never be too small and never be too large. And that's what makes this function so magical. For the first time, we have true responsive scaling of fonts, thanks to this clamp function. Now, all these functions, min, max, and clamp, are fairly new, and we don't really use them much in production yet, but they are fully supported across all modern browsers. So you should use them whenever you have a chance, especially the clamp function because it gives you this nice dynamic typography. But I highly recommend trying out these functions and really familiarizing yourself with them because they will solve many problems that you previously had with media queries, and they'll come in and help out solving all of those snapping issues that you had, because in many cases, you don't actually need a media query. What you need is min, max, or clamp. Drop caps, making the first letter of a paragraph or a document much larger and stylistically different than the rest of the text, has been a stylistic element in typography for hundreds of years. In classic handwritten manuscripts, you'll often find drop caps turn into elaborate works of art that take up a significant area of the page and provide illustrations supporting the material of the text itself. We can add drop caps to any text element using the first letter pseudo-element, often in combination with the first of type pseudo-selector. In this example, I want to add a drop cap to the first paragraph in this document. So that would be this D up here. And I want the drop cap to appear inside the container so that there's a big D here, and then we read the rest of the text. And maybe I'll add some additional styling to make it look good. To do that, I need to target just this item, and I can do that using CSS. So I'll say I need a paragraph, and what I want is the first paragraph in the document only. So I'll say first of type. So that gives me only the first paragraph, and then inside that paragraph, I only want the first letter. So we'll use the first letter pseudo-element. So first letter. In CSS, we read selectors backwards. So in this case, we are saying, give me the first letter of the first of type P. So that would be just D up here. All right, now that we have it, let's make some stylistic changes to it. The first thing I want to do is make it much bigger than the rest of the text. And here I'm going to use an M value because then I'll size the drop cap relative to the existing text. You'll remember the M value relates to the containing element. So if I set the font size here to 4M, it'll be 4 times as big as the rest of the text. So save that. And we get a much bigger D, but it's not a drop cap. It just is a very large D that doesn't fit with the rest of the content. What I need to do now is float this first letter into the rest of the content so the rest of the content wraps around it. I can do that by setting float to left. Save that, and it flows to the left. Now, because there's a chance that this might be a right to left language, I'm actually also going to put in float and then set it to inline start. That way, for modern browsers, it'll use float inline start, and for older browsers, it'll use float left, and that way we'll get cross-browser support as much as possible. Next, I need to try to shift this around a bit, because it doesn't look exactly like what I want. So I'll say, maybe add some padding to it. Let's just try. So I'll say padding, maybe 2.2 rem at the top, or 0.2 m, because I'm using m sizes here, and 0.1 m. So that will give us some breathing space around this item. Oh, well, now it's kind of bumped in a bit. It looks better. Maybe we should also give it a background color. So I'll say background color and pick some HSL value here. So I'll say 0 for red, and then 59% saturation and 41% lightness. Will give us this nice red background color. Then we also need to change the foreground color to the text, and we should probably set that to white. So color white. And it's kind of butting up against the text. So I'm going to add some margin here as well. Let's see. Let's set it to 0 at the top and 0.1 m and 0. Let's see what that looks like. Now it's starting to look like something. It's not exactly what I want. Oh, that's why. There we go. So now it's really starting to look like a drop cap, right? Maybe we can bump it down a bit. So I can say 0.3 m at the top, perhaps, to see if I can. Oh, that was way too much. You're kind of getting my point here. I'm just messing around with it to see if I can get it to look roughly the way I want to. And then finally, just for some flair, I'll set a text shadow. And I'll set it equal to 3 pixels and 0 offset, and then set an HSL value to the same as I had up here. So we already have 0.5941. That would be that red color, and here I want the color to be a lot darker, so I'll say 15 instead. That way we get a darker version of the same color, so it's better than just putting a black drop shadow. So what we have now is a hard shadow. There's no blur in it at all. It's offset by 3 pixels. And this very much looks like a proper drop shadow. The cool thing is this drop shadow is still part of the regular text. So if I highlight the text here, I can highlight the D as well. And if someone was using a text-to-speech browser or any other assistive technology, this would still read out as drop because it's still the word drop. What you're seeing here with the drop cap is purely stylistic and imposed by CSS. It's not changing the content in any way, and I'm not adding any extra HTML to make this work. The drop cap is a great visual tool to notify the reader this is the beginning of a defined portion of the text. That said, Using drop caps introduces accessibility issues because it increases cognitive load for people like me who have dyslexia and for other people with other reading challenges because it makes it a little more difficult to read the first word. It kind of looks to me like it says drop caps. So I have to really think about it to see, oh, it's a drop cap and these letters belong to each other. So in other words, use this with care and only as a stylistic extravagance when absolutely necessary. So just don't put drop caps on every single paragraph. Use it as a sprinkling of style when absolutely necessary or when you really want to make something look different. When trying to fit text into specific designs, especially if that text is dynamically generated, it's sometimes necessary to truncate the text to make it fit. This can be done at the markup level, but in responsive environments, it's often necessary to dynamically truncate the text based on the current display. If you do it at the markup level, you may not get the result you're looking for. Using CSS, we can truncate text based on the outer bounds of the container, or we can specify the number of displayed lines. And here's what both of those approaches look like. In this example, I have a card where I want to control the height of the card. Specifically, I want to limit the headline in the card to a single line of text and the body text to a maximum of 4 lines. I enforce a single headline by setting its white space property to no wrap. So I'll say h2. White space, no wrap. That results in the text not wrapping inside the container, and therefore it spills out over the right-hand side, which is not what I want. So I'll also say overflow hidden. That will hide any overflow, so you can see here the text gets cut. But that also looks strange, so I need to do one more thing, and that's where the truncation comes in. I can then say text overflow, ellipsis. And now the browser will say, okay, so I'm going to truncate the text and then add an ellipsis at the end, however much space I have. So if I go in here, I can change the width of this container. So let's see, right now, the width is set up here with a min value. So if I set this to like 40 ch, it'll be wider. And you can see the truncation happens automatically. So there's more space and this ellipsis appears at the end anyway. So this setup here using white space, no wrap, overflow hidden, and text overflow ellipses is a really clean way of truncating a single line of text. But that's the important part. This only works for a single line of text. If, on the other hand, I want to truncate a block of text like this and want to limit it to a certain number of lines, I have to use a different approach. And I need to warn you in advance, this approach is still kind of bleeding edge. It doesn't work consistently everywhere, and it has a browser prefix on it. Even so, let's try it to see what happens. So I'll grab the card paragraph. So I'll say card paragraph. And inside card paragraph, I'll first set the height I want. So that's the height of the container for the paragraph. So I'll set the height here to 4.5 rems, just to account for enough space. What you're seeing now is we get a container that's 4.5 rem, but the text is overflowing as it should. So that means we also need to set overflow to hidden. Now that will truncate the text, but we don't have proper truncation here. I'm also noticing the height isn't high enough, so maybe 5.5, no, 6.5 maybe. We'll just experiment until we hit it. So yeah, that looks pretty good. Okay, so now we have the 4 lines we want, but we need that truncation ... at the end. To achieve that, I need to do a bit of CSS hacking or using some cutting edge features. So I'll first say display, and then set up -webkit -box. So this is a display property that will eventually make its way into all browsers, and it'll just be called box. But since it was introduced with WebKit and it's still not fully ratified, it is put in with the browser prefix. So that's why we're saying WebKit box. This is necessary for the rest to work, but when I save this, you see nothing changes. We're just declaring this as a box display model. The next thing I need to do is set in WebKit and line clamp. And line clamp does exactly what it sounds like. It clamps the number of allowed lines. So in this case, I'll set line clamp to 4 and save. And again, nothing happens. That's because we need one more property. That one is called WebKit, again with the browser prefix, box orient vertical. Like with WebKit line clamp and WebKit box, this is still experimental, but it's actually supported by all modern browsers. So this will work. When I save it, look at that. We get this little ellipses at the end. And this is not dynamic. So if I go in and I change the line clamp to 3, it gets cut down to 3. Now, you'll also notice that what's happening here is the browser is just adding the ellipses at the end of the third line. It is not cutting the content. So the overflow here is still not working properly. And that means I need to reduce the height to maybe 4.5. So you need to do some work here to make sure everything is working properly. But with this approach, using display, WebKit box, WebKit line clamp, and WebKit box orient, you can truncate multi-line text using CSS. Like I said, cutting edge, but works in all browsers. I expect in the near future, we'll see all of these features be baked into the browsers properly, and we won't have to prefix it. By that time, I'll probably update this video. But for now, you can do this, and it'll work in most browsers. The browser's user agent styles have predefined styles for all standard interactions, and that includes selection highlighting. Use your cursor to highlight any text, and it's typically displayed with a blue background, and sometimes the text color will change as well. For some designs, it may be preferable to change this selection highlight color or appearance to either make it more visible or to conform to the overall design language of the page or site, or just because it looks cool. For all of these scenarios, we have the selection pseudo-elements. Let me show you how that works. I can apply this globally to the entire page or just to a specific element. So in this case, I'll apply it only to this paragraph that I have here. So I'll say demo area, that's the whole blue area. And then I'll say for paragraphs selection, that would be the pseudo element. And then inside here, I can now define, for example, a different background color. So I'll say background color, and I'll set it to, let's see, some hsla value. So let's see, 51, that's a yellow, and then 96%. And 51%. So that'll give us kind of a deeper, more vibrant yellow color. And save this. So now when I select text up here, it's still the same blue. But if I select text down here, it's now yellow. And I could go further here. I could apply additional styling if I want to, outlines and font highlighting and whatever I want. This is styling just like any other styling, except we're hooking into some specific browser behavior. One important note here. Because selection is a pseudo element, it must be either applied globally or by just declaring a : selection rule on the entire document, or on individual elements or containers. If you apply it to a container element, it will not work though. So if I said something like demo area and then selection, so like this, then it won't work because we're not actually targeting that element. So you have to go all the way down and target the specific elements you're going to be highlighting, like in this case, a paragraph. If you want it to be global, you just declare : selection with nothing else, and now you'll see it'll be yellow up here as well. So make sure you're targeting the right element. Oh, and in case you're wondering, if you ever want to automatically highlight some content in your text, you can do so by manipulating your HTML. So if you go into your text here and just find some stuff you want to highlight, let's see, like here inside my paragraph, I'll just set up a mark element and wrap whatever text I want to automatically highlight in that mark element, like this. And when I save it, you'll see that it automatically picks up the selection color that I chose, and this item will then be automatically highlighted. This is what you see when you go to a site like Wikipedia and you're making a search for a specific term. It'll show up like this on your search results because the mark has been injected using JavaScript. So if you ever find you need to highlight something and you want to use the selection process, you can use the mark element to do so in your document or inject the mark element using JavaScript. And on a final note, remember that text selection highlighting is a built-in accessibility feature. If and when you change it, make sure you preserve or enhance the accessibility of the highlighting. Highlighted text must be clearly visible and distinct and must have enough contrast between background and text and the font itself to be viable. If you do something like go in and make the highlight background the same as the background itself, you're working against the principles of the web and you're creating an inaccessible experience. So make sure that anytime you change the selection, make it look even more high contrast so it's easier to spot. The line height property describes the height of the line box. That's a virtual box around a single line of text. The default line height value in most browsers is somewhere between 1.15 and 1.2, meaning the font size multiplied by 1.15 or 1.2. And you'll find that in many cases, this default line height feels too tight. There isn't enough space between each of the lines, especially when the font size is relatively small. Then again, for a larger font size, like you see down here in this heading, the line height may be too great, and reducing the line height may improve the appearance and readability of the text. So you can grab any element in your document and change the default line height, and it's often a good idea to do so to improve the typography of your site. Let's say, for example, I want to increase the line height of the paragraph slightly. I go in and grab my paragraph and I just say line height. And from here, I can now use any of the length units. So I could do this using pixels or ems or rems or percentage or whatever other unit I have available to me. However, I'm going to use a unit-less measure. So I'll say 1.4 and save this. What you see in the browser is there's now more space between each of these lines, and this may or may not be what I want. I often end up experimenting and landing somewhere between 1.3 and 1.4 for paragraphs. Now, the reason I'm using a unit-less measure here, you'll notice there's no pixel or em or percentage or anything else, is when you use a unit-less measure like this, you're saying grab the font size and multiply it by this value. That way, this line height is relative to the font size and will always have the same relative relationship to the font size no matter what the font size is. It's simply easier than using units, and it's more accurate that way. So for example, if I want the line height to be twice the font size, I would simply say 2. And now we could basically fit another line in between here. If you want it to be 4, you say 4, and so on. And you just make it a factor of the original font size. It also means if you set it to 1, the line box will be the size of the font itself, which, as you can see, is way too tight. So like I said, I normally land around 1.3 for paragraphs, which feels comfortable to read. Now, line height can also be used to do things like smoosh the lines of headings closer together. Look at this heading down here. You'll notice it almost feels like there's too much space between the lines. So we can target that heading and set its line height to maybe 0.8. See if that works. That's too tight. How about 1? Better, maybe 1.1. So as you can see, there's a lot of experimentation going on here, and you can really customize each individual container to make sure that the line height feels exactly right. The final really useful place to use line height is if you want to add more breathing room to list items. This is especially useful if you have just text lists like this, because as with paragraphs, the default line height is too tight. There's just not enough space here. For that, you can simply target all the list items and say line height and just try some different heights. So let's say 1.5. And now we get some more space. Maybe that's not enough space. Let's try 2. And as you can see, we're changing the display of the list without actually doing anything to the styling itself. So we're not changing the box around each of these items. We're just changing the line height, which gives us more breathing room. Custom properties allow us for the first time to use true variables in CSS. And those variables can be literally anything you see on the value side of a CSS property, a full value or any part of a value. In this example, I've used 2 custom properties. I've defined them in the root element so that they're available to the entire CSS sheet. And then down here in the card section, I've used the first custom variable line width to define the line width of the border. And I've used the key color to define the color of the border. So here you see how I'm using 2 separate custom properties in one property declaration inside one rule. And that's kind of the point of a custom property. You can use it to replace any content with a variable. Now here's the thing. Custom properties open a whole new world of possibilities, but some of those possibilities are not immediately obvious. Say, for example, you have a JavaScript component like this card here, and you want it to respond to the overall style in the view it's presented in, but you don't know if that style has the information you need. You can imagine you'll create a standalone component, and then if there are custom properties defined in the overall document it's presented in, then the component would hook into those custom properties. But what do you do if those custom properties are not present? Well, in that case, you need a fallback. And the cool thing is the custom property declaration allows you to provide a fallback. You see, when you call a custom property like this, var dash dash and then the name of the custom property, you can amend this by adding a comma and then add a default value. So I can say that the border width default value here will be 1 pixel. And then the color default value will be black. If I save this now, nothing happens because I have the custom properties. But if I now comment out the custom properties at the top here, you'll see I fall back to the default values, so 1 pixel border and a black border. And this gets even more interesting because you can actually have the fallback be another custom property. So you can define a custom property and then say if the other custom property isn't present, then you use this custom property instead, and you can nest custom properties inside one another to make a really interesting and dynamic display. But the key here is you can always provide a fallback for any custom property by just setting a comma symbol and then defining the true value that will be present if the custom property is not present. Using this feature, you can safely develop standalone and self-styling components that respond to custom properties if and when those custom properties are available. The cool thing about custom properties is you can nest custom properties inside other custom properties as much as you like. They are, after all, just variables, and as long as they're defined, we can use them. This custom property nesting can be used to create rudimentary functions in CSS. So let me show you a very basic example of this just to get your imagination started. I want to create this fancy card with a faux drop shadow, and I want there to be a consistent rhythm between the width of the padding, the width of the border, and the offset of the drop shadow. For this, I'll use a series of custom properties that are all rooted in one single unit. That way, if I change this single box unit, then all the other custom properties will change with it. So let's take a look at how this is all wired together. I have this box unit that's currently set to 1 rem. Then I say the box offset, which will be the offset of the shadow here, will be a calculation of the box unit that I defined above times something. So right now it's just times 1, meaning nothing changes, but we'll change that in a little bit. Then we have the box padding, and box padding is right now just the same as box unit, but I've set it up so that I can change it later without having to change box unit. And finally, we have the box border, where we do a calculation of the box unit and divide it by 2, so that the border is half the width of the padding, effectively. Then when I scroll down in my style sheet, you'll see how I create this faux shadow. It's actually before element, so it's a pseudo-element that's been projected in behind it. It's placed behind the main element using z-index -1, and it's absolutely positioned, and then we use top and left to position it relative to the box. Now, what you see here is one example of this crude function thing I was talking about. We have this value in box border, but the value is a plus value. To change it into a minus value, so a negative value, we do a calculation and say -1 times, and then the value, and out comes a negative value. Then if we scroll further down, you'll see I've used these values in several different ways. So in the width of the card, I'm using the box border as a calculation. You can see it here. So we are subtracting the border times 2 to calculate the width. There's a lot of stuff going on here. But the key is all of the custom properties that are being used down in the style sheet are actually controlled by this single value up at the top. So if I change this value from 1 to, say, 2, look over here in the preview and you'll see what I mean. So when I do that, I'm actually changing all the values. So now the padding changes, the border changes, the offset changes, and the size of this drop box changes. If I change it to like 0.5, save again, you'll see everything changes. We have this rhythm that happens because of all these nested units. If, for example, I decide that I think the offset is wrong, I want more offset, I can go and increase the multiplication here to 2, or maybe that was too much, 1.5 perhaps. until I get the exact result I want. And I can do the same with the padding. If I think the padding should be thinner or thicker, I can just add a calc around it and then say times 1.5. So if I want the padding to be 1.5 and the offset to be 2, I can do that, and then we get a different relationship. But the point is, all of this can now be done based on this single unit. And you can imagine you could have several situations where maybe a media query would trigger the box unit to change depending on the width of the screen. And then all of these other variables would change accordingly, so they would always have the same rhythm in the layout without having to change every single value all the time. The ability to switch between light and dark mode, either automatically based on the browser or device preference or through user interaction, has become an expected feature of apps and websites alike. With CSS, we can trigger dark mode both automatically and manually and control exactly what light mode and dark mode actually means for our apps and sites. To trigger dark mode automatically, we detect the user preference settings with the prefers color scheme media query. The default color scheme is always light. So if you are setting up a site like this, you would probably use a media query that just detects prefers color scheme dark and then provides separate styles for dark mode. Here's the thing. We can make this process really simple and straightforward using custom properties, because that way, instead of redefining all the colors and styles and creating essentially two separate style sheets for light and dark mode, we just define all the colors using custom properties, as I've done here. So we have the background color, the font color, and the key color. And then we use a media query to change those custom properties if dark mode is detected. So here we are redefining background, font, and key color. But of course, this brings up the question, how do I see this in my browser without changing the settings on my computer? Well, if you're using Firefox, it's pretty straightforward. Open your developer tools, and you'll see in the style inspector, we have these two buttons for light mode and dark mode. So if I just click this button here, the site switches to dark mode. And you'll notice that the dark mode from my styles kick in. So we have a slightly lighter purple color. There's a almost white text color and an almost black background color. If I switch back to light mode, the other colors kick in, a darker purple color, and then a white background and a black font color. For automatic detection, this is really all there is to it. And you can also see that this approach can be used with JavaScript as well. All you would have to do is add a button somewhere for light and dark mode, and then wrap these rules in some sort of other CSS selector. So the simplest thing is to use JavaScript to append a class to the body element, and then have a class that says either dark or light, depending on what you're targeting. And if that class kicks in, then just apply these same rules. And again, using custom properties, this is really straightforward because you're just redefining the colors in the custom properties. You're not writing a whole new style sheet just for these different color modes. You may have noticed throughout my examples that I use hsl and hsla to define colors, and you may also know that the more common color markup is either hex colors or RGBA. There's a good reason I use hsla though, and once you know it, I'm pretty sure you'll start using it too. So here's a basic example. Using custom properties, I've set up a system where I can define a hue once and then create many different variations over that same color to create consistent color schemes. You can see over in the browser, I have that color scheme. It's this brownish yellow, and then it gets fainter and fainter. And if we look over in the code, you see what I've done is set up a custom property called base color, and I've set it to the value 42. And then I've set up three colors, color dark, color medium, and color light to correspond with each of these, dark, medium, and light. And inside these custom properties, I've used HSL and then grabbed the base color, that's the one defined up here, and then I've set different values for the saturation and the lightness for these colors. So I'm using the same color throughout, and I'm just changing the saturation or the lightness to change these colors. And that means no matter what I do, we're still working within the same color space, and I never have to try to adjust my colors so they don't clash. Now here's the thing. This setup here is only possible using HSLA. If you were trying to do the same with RGBA or hex, you would have to do a ton of math. So let me explain what's going on here. HSLA stands for hue, saturation, lightness, and alpha. And the last one, alpha, is optional. You can choose to make this transparent or not. Here's how HSLA works and why it's so interesting. The first value, the hue value, is the degree on the color wheel. So you go anywhere from 0, which is red, all the way through to 360, which is again at the top of the color wheel, which is red, and pick a color. So if you want green, you would say age value is 120. That's 120 degrees on the color wheel, and that will be the color throughout. So you pick a color using that first value, the hue color, and it will always correspond to this color wheel. The next value, S, is for saturation, and this is the percentage of color saturation. If you set that percentage to 100, you get full color. If you set it to 0, you get no color at all, so it's completely gray. And in that zone between 0 and 100 is where you'll find all the variations over that color. So if you want a really bright color, you go closer to 100%. If you want a very subtle color, you go closer to 0%. The L value is for lightness, and here you can imagine it's like projected light onto the color. So here, 0% is black, meaning there's no projected light at all, and there is no color as a result. So if you use hsla and you want to create a black, you just set the last value, the L value, to 0, and then you always get black. 50% is just in the middle, and 100% gives you full brightness, meaning the light is so bright that it's blacking out or it's whiting out everything, and you get full white. So again, if you want full white, you can just set any color to 100% L, and then you get full white. The final value, the optional A for transparency or alpha, is a value between 0 and 1. So here, 0 is completely transparent, there's no color at all, and 1 is completely opaque, and you have full color. What does this mean? Well, in simple terms, it means if you're working with a color scheme, all you need to do is set the first value, and then you can change this entire display. So right now it's set to 42 degrees, which is some sort of murky yellow color. If I change this value here to 0 and save it, you'll see now we're working in the red color space. If I change it to 120, now we're working in the green color space. If I set it to 240, now we're working in the blue color space. So using hsla, you can very quickly pick a color and then pick the color variation you want by varying either the saturation or the lightness or both. And it just makes it a lot easier to work with colors. Now you see this and you think, well, you could totally do that using RGBA or hex as well. And of course you could, but let me show you how it's different if you work with one of these other color spaces. So I'll set the background color for my entire demo area to an hsla color first. So I'll say background color, and then we'll set it to the same as what we have above, except I'll put in all the values so we can actually work with it. So I'll say hsla or hsl, and then we have 240, comma, 85%, comma, 50%, which is the default, and put a semicolon at the end and save that. So now we have this blue background color you see. Now in VS Code, if I want to change this to a different color value, I can just hover over it and then click on this bar at the very top. Now notice what happens underneath. I click on it, it goes from HSL to RGB and then to hex, and then back to HSL again. Now pay close attention to what's happening here. When I'm on HSL, I'm saying the color is blue, so 240, the saturation is 85%, and the lightness is 50%. If I switch to RGB, I'm saying in a red, green, blue color space, I have 19 values of blue, 19 values of green, and 236 values of blue. And what happens now is for each of the colors, you have a space between 0 and 240, and you have to pick the combination of the red, the green, and the blue to meet any color. Now imagine trying to pick a color using this color space by simply using a number. Or even worse, look at the hex number. The hex number here is actually a codification of that RGB value. So it's even more complex, and you simply cannot go into this and say, I'm just going to switch this quickly to green. You would have to open a color picker and then find what green is. But when you're working with HSL, you just go in and change the first value, and then you get the color you want automatically. Now, using hsla takes some getting used to, but once you get the hang of it, you'll never want to use any other color, because unlike hex and RGBA, hsla actually makes sense to the way we humans think. All you have to remember is the color wheel, and that you're placing a color on that color wheel. And like you've seen, if you have a color in hex or RGBA and you want to know what it is in hsla, you just hover over the color, click on the bar at the top, and you can switch between all the color modes until you get the hsla value for any color, and then you just start using that one. Now that we have 3 main layout modules in our CSS toolkit, the question often comes up whether we should be using flex or grid or float, more commonly named flow, in any one of our layouts. I often see people say things like, now that we have grid, we no longer need flex, or now that we have grid and flex, we no longer need float. So let's clear this up and figure out when to use each and why all these layout modules still have a role to play on the modern web. To help out, I've created a simple flowchart, and we can use that anytime we need to make decisions about what type of layout module to use. It starts with the very first question, which is, are we imposing a 2-dimensional layout on this page? And if so, is that layout controlling all the items within it? Basically, are we drawing a grid on the page and then placing content on that grid? Or are we in some way saying, here's a box, I want to control what happens inside that box? If that's the case, use grid. If it's not the case, then we go to question number 2. Is this a dynamic multi-item layout, meaning there's one or more items that are controlling their own dimensions and are content out, so the size of the item controls what happens to the adjacent items? And is this happening across one dimension with or without wrapping? If that's the case, it's probably a flexbox, but in some cases, it may also be a grid. So here it's worth experimenting. The general rule is if you're working with a list and you just want the list item to appear one next to another, or maybe wrap down to a second line, it's probably flex. But in some cases, if you want more control, you can also use grid to achieve the same effect. If the answer is no to those questions, then we get to question number 3. Is this layout in the content flow? Are we using text wrapping or somehow else laying things out in context? If that's the case, then we are using the default flow behavior of the browser, maybe with floats and clears. If you answer no to all of these questions, something has gone wrong, and you need to go back to the top and ask the questions again, because in all cases, you will have either an imposed 2-dimensional layout, a 1-dimensional layout that's content out, or content flow. There are no other options in layout. Except there is one overriding question that supersedes all of these, which is, are you doing any type of vertical stacking across the z-axis? Meaning, are you stacking one item on top of another item to create some form of 3-dimensional experience? In all cases, if that's the case, the answer is grid, because grid is the only tool you can use to actually stack one element on top of another and control what is happening with them. So this flowchart is the one you'll use anytime you wonder, should I be using grid or flex or flow? And based on this flowchart, you'll get a firm answer, and you can then move forward safely. By default, the children of flexboxes and grids are placed right up against each other with no breathing room. You can see that here in my example. We have a grid. There's no space between the cells, and we have a flexible box or a flex box, and there's no space between each of the flex items. This makes sense. From a layout perspective, you often want a tight grid or a tight flex box, and then each of the items can then position themselves. However, there are also times when you need space between these items, either to visually separate them or to meet a specific layout or design goal, or to just separate content in a layout. When CSS Grid was first introduced, it came with a new property called Grid Gap that added gaps or gutters between the cells inside the grid. You could then set a column gap or a row gap or both using this property. Let me show you how that works. So I can go into my grid here and say grid gap, and then I'll set one value. So I'll set it to 1 rem. If I set just one value, then the value is applied both to the rows and to the columns. So we get 1 em on the rows here and 1 em between each column. If I set 2 values, so 1 rem and 2 rem, and save, you'll see the first value then applies to the rows here, and the second value applies to the columns. But if I hover my mouse over this item here in VS Code, it says, this property is obsolete, avoid using it. That's because as we started using both grid and flex, users of Flexbox started asking the question, why can't we have gutters or gaps in Flexboxes? Why is it only applied to grid? If you've ever used Flexbox, you know that to create a faux gap, you have to do math to figure out how big each of the boxes should be and then add the space in between. It doesn't really work all that well. As a result, the CSS working group expanded the gap principle to also include flexbox. And now we have a new property that's just called gap. It works the exact same way, so I can say here 2rem and 1rem just to reverse it and save. And you'll see it works the same way in grid. The first value is the value for the rows, the second value is the value for the columns, and if you set just one value, it applies to both. But we can now use the same rule for flexible boxes as well. So if we say display flex, we can say gap and 1rem, and watch the box down here, save it, and now we have gaps between the boxes as well. And the cool thing is, this property doesn't change the size of the grid or the flexible box. Instead, it reduces the size of the items inside to add a consistent gap between items. Now, in grid, we've always had this, so it's not a surprise. But for Flexbox, this is a major improvement because, like I said, before we had to size each of the items inside the Flexbox and then do the math of what should each of these items size be if we have these gaps, and then what if we accidentally added an additional one at the end, then the size would be off and we would have to do all this math. That's no longer necessary. The gap property works both on grid and flex and will always add gaps between the items by reducing the size of each items, and you then have complete control and you can have consistency across your flexible boxes and your grids. The pseudo-elements before and after are used for a variety of purposes in CSS, the most widespread one being as part of a clearfix to prevent boxes with floated elements from collapsing. You see one up here, and I talked about this earlier in the movie about the flow root value. With the introduction of flex and grid, pseudo-elements suddenly got an interesting new use as true items of grids and flexible boxes. You see, if you have a pseudo-element appended to a flexible box or a grid container, that pseudo-element automatically takes up a slot in that container as a flex or grid item. Now, this can be used to do some very interesting things, and it can also cause all sorts of interesting problems. So let me just show you what happens when you add a pseudo-element to a grid here. So I've already marked it up, and I'll just uncomment it. In this example, we grab demo area UL, so that's this unordered list here that's displayed as a grid. And then we say, before this item, we want to just put in a new element that says, I'm before the pseudo element. So save that, and look at that. The before element appears inside the grid as a true grid item. And as a result, all the other grid items get shifted to the right and down to accommodate this new element. If I then also add an after element to the same grid, you'll see that gets added here at the bottom as a true grid item. So now we have two extra grid items we have to account for. This is what I mean when I say pseudo-elements become true children of a grid or a flexbox. They really take up space within the grid or flexbox, which may cause some interesting problems from time to time. So let me just comment out these again and then activate a clearfix instead. So this is something that I've come across myself in my own code, and it took me a while to figure out what was going on, which is why I'm adding it here in the course. So if you apply a clearfix to all elements within a page, something that's very normal to do in CSS frameworks and things like WordPress themes, very strange things start happening with your grids and your flexible boxes. So look at this now. When I save this, you'll notice there's this weird line that appeared at the bottom of my grid. And if we scroll down, you'll also see there's a weird line that appears on the right-hand side of the Flexbox. So what exactly is happening here? Well, we have to look closely at the code of the grid and the Flexbox. So if we look at the grid, you'll see, let's see, where is it? Here, the grid has a gap of 0.5 rems, which is what's causing the gaps to appear here. And what we're seeing at the bottom is the gap, and then there's a box underneath, so a grid item, but the grid item is nothing, so therefore it's just showing the gap. And the same thing happens in the flexible box. There's an additional item over here on the right-hand side, but it's collapsed to 0 because the current definition of this clearfix is that the size is 0. So therefore, a cell is being taken up here, and it's being taken up over here, but nothing is being displayed. As a result, if you're not aware that this is what's happening, you'll sit there and try to figure out how to get rid of this gap, either by setting a negative margin or think that maybe it's a padding or there's some overflow problem. But what's actually happening is we have this invisible grid item. The easiest way to see what's going on is to go into the developer tools. Here we have our unordered list for the grid. And at the bottom, we can see after. And when I hover over it, you can see here there is a grid item there, but the height of the grid item is 0, so therefore you can't see it. But that's what's causing the content to bump down. Same thing in our flexible box. If we inspect this element here and then go to after, on the right-hand side over here, there is an item, but that item has a height of 0, so therefore it doesn't appear. That's why we have these overflows, and that's why it's very important if you're using grid or flex in your project to not apply a clearfix just globally to every element, because it'll cause problems like this. But just as importantly, it's worth knowing that you can now introduce additional elements to your grids and your flexible boxes by using before and after. And this can be used in some really interesting circumstances to add additional information or to add additional features to your grids, as you'll see in the next movie. In my mind, the most revolutionary feature of CSS Grid is it allows us for the first time to lay things out in the third or depth dimension in the viewport. By that I mean we can literally stack elements one on top of the other inside the grid to create previously impossible layouts. Let me show you a practical example using a figure, some pseudo-elements, and an image. What you're seeing here in the browser is just a figure element. There's nothing fancy here. There's no dividus, no like multiple divs nested inside one another. Looking at the markup, we have a figure that wraps around an image, and then a fig caption. And inside the fig caption, there are 3 elements. There's a block quote, there's a cite, and there's a regular paragraph. Now, if you look at these items as I scroll over them, you'll also notice that they are positioned specifically within the viewport, and that's all achieved using grid. So if we go and look closer at this figure, you can see that there's a grid applied to it. If I activate the grid here and then activate the line numbers, we can see what's going on. So there's an overall grid around the entire figure, and all the elements within the figure are positioned on that grid. So now we can go in and look at each item in turn. So here we have the image first. The image is placed using grid columns 4 and 5, so that's number 4 and 5. And grid rows 3 and 4, so that would be 3 and 4. So that's placed in the main grid. Then the fig caption here actually contains its own grid. So if you look closely here, you'll see inside fig caption, it says display grid, and we can activate that grid as well. It's a grid that sits inside the main grid. Here's the second grid. And inside that grid, we then position the block quote, the cite, and the credit. So that explains the main content. But what on earth is going on with this yellow background thing here? Well, that's also positioned on the grid. If we look closer here, you can see it sits here. But that doesn't appear in the markup. There's no element for that background, and it's definitely not a shadow because it's placed inside the grid. It's actually an after element. So that's a pseudo element that's been stacked into the grid. So here we have card, : after. Then the content is nothing, the display is block, and since we are placing it inside the grid using grid column 1 to -2, again, I'll display the line number so you can see it, line 1 to -2. So that's, if we count it backwards, you can see down here, -1, -2. And then we display it from 1 to -2 in the rows too. So that's from 1 to -2. Then we can position it exactly where we want it within the grid. And then we just use z-index to dump it in behind the other content. This setup now allows us to use a simple figure to create a very advanced 3-dimensional layout with multiple layers, because there's actually a third layer here as well. It's this before. And the before is, again, positioned on the grid, just in a different position. It's sitting between lines 2 and -1 and 2 and -1. And then it has the background color white, but we can change that background color to something else so you can see it. So here we have another element that is independent of the card itself and can be placed in. You can put an image in it if you want to. You can put text. You can do whatever you want. And all of this is made possible by this grid stacking. We are literally placing items one on top of the other inside the grid and then displaying it as if it was just one cohesive element. This is really quite magical. And the most magical part about it may be that if you turn the grid off, so if we just say, take away display grid, and scroll down, and then take away the other grid as well, so that would be here, you'll notice the fallback to content when grid is not displayed is acceptable. Of course, I would add some additional fallback styles here to get rid of this yellow background, for instance. But because we're using a pseudo element to generate that yellow background, it just doesn't appear when we turn the grid off because it doesn't exist within this context. So Using grid and stacking things vertically allows us to do things that were previously not possible without adding a bunch of extra markup. That's the most revolutionary part of CSS Grid, in my opinion. Fixing or sticking elements to specific locations within the viewport has been a staple of application and web design for a long time. But up until recently, doing this required a fair bit of JavaScript and some math just to figure out when and where these elements should stick or be fixed. And it was really error-prone because it was JavaScript-based. In modern CSS, we now have both the fixed and sticky values for the position property, and we can do all of this without any JavaScript. So let's see how both of these values work and how you can use them. We'll start with fixed. So the fixed property is typically used to do things like fix a menu or something to the bottom of the screen. So in this example, I've just created a footer, and I say I want to fix this to the bottom. What that means is no matter where I am on the page, I should see the footer fixed to the viewport. The most obvious use for this would be if you have a menu or navigation or something else that you want to fix to the bottom of a mobile device so that it's always readily available where the thumb is when people are using the application. All right, so right now it's not fixed. You can see I can scroll up and it goes away. To fix this item, I simply go to the item and say position fixed. And then I also have to declare the position of the item itself relative to where it is. So in this case, I'm saying position fixed, bottom 0. So I'm saying fix it and then position it to the bottom of the viewport, 0 pixels from that bottom. When I save this, the footer automatically appears on the bottom. And as you can see, when I scroll, it is now fixed, meaning no matter what I do, it does not move. Now, there's one important thing that you have to keep in mind when you do this. When you are pulling things out of context, like I'm doing now by saying position fixed, you are also taking away the space that it would be taking up. So that means you need to accommodate for this new space that's being blocked by the fixed item so that it's not covering some other content. And what you'll notice is here, up in the demo area section, I've set the bottom margin to 5 rem, and that's to accommodate for the space that's been taken up here. If I set that to 0 and save, you'll see the fixed content is now blocking the very bottom of the document, which is not great. So just keep that in mind. If you fix anything to any location, it means it's sitting on top in 3D space on top of other content, and you need to make sure that the other content underneath somehow accommodates for this blocked area. All right, so fixed is fairly straightforward, and once you see how it works, it's easy to use. What about sticky? Well, sticky works a little bit differently, and in this example, I want to stick the navigation. Now, sticky means instead of it being fixed to a specific location, we say that under what circumstance should it start to stick to a specific location. So if I just grab this main nav here, and uncomment it, you'll see it says position sticky top 0. So that means when this item here, when the element nav comes to position 0, so top 0, then it becomes sticky, meaning then it doesn't move anymore. Watch what that looks like in the browser. So right now, the item is sitting down here, further down on the browser, so nothing is happening. I can scroll, nothing is happening, but the second the top of the element hits the top of the browser, meaning top 0, it becomes sticky. See? So now it sticks to the browser. And you can imagine, if you were doing this with JavaScript, it would require a lot of math because you'd have to figure out how tall is the browser totally? How tall is this item? Where is the top of the item? At what point in the scroll behavior does the top of the browser meet the top of this item? And only then do you change the CSS property from static to fixed. But then you also have to account for the content being pulled out of the stream, a bunch of stuff you'd have to do in JavaScript. Or you just do it with CSS and it works automatically and it works really well. Only thing you need to remember when you're using sticky is when you stick things to the browser, wherever you stick it, all the contents below it will appear behind. So for example, in this navigation menu here, if I don't want the image to appear behind the navigation menu, I need to add a background color. That's why you see there's a white bar here. That's the background color for the entire navigation element. If I go down here, let's see, you can take the background out for a second, and you'll see it starts looking strange, which is not what we want, right? So if I do this, It's still sticky, but it's not clearly demarked that this is a separate element. So you have to remember to put in backgrounds or borders or whatever you need to make sure there's a clear demarcation between the sticky element and the rest of the content. So now you know you can do all of this with CSS without a single line of JavaScript.